Hello, I'm Eleanor Bassett. I am a rangeland research ecologist working with Range Branch, and I work out of Williams Lake, British Columbia. Today I'll be presenting on the findings of Brian Wallace, the soil scientist, and Reg Newman, formerly of the Research Branch, working out of the Thompson-Okanagan region, and their findings on the post-wildfire seeding in a low elevation dry forest after a decade of vegetation monitoring. The area that was studied was the Strawberry Hill wildfire. This was a wildfire that was started in 2003. It ended up being a high burn severity fire, and it was near Kamloops, British Columbia. So Kamloops on that little map there at the bottom is that little red dot. And on this map here, you'll see that there's a line in orange, and that orange line is showing the boundary of the fire. After a fire, there are a lot of management considerations. There has been a loss of desirable forage. There can be susceptibility to invasive plants coming into this newly burned area. There can be a change in cattle distribution, which can be good and bad. The change in cattle distribution could be because there's no forage opportunities. It could be because there have been range barriers that have been burned. And there can be issues with erosion now that those plant roots and stabilizing forces have been destroyed. I wanted to start out by just looking through the lens of the cattle industry. So giving an example here of an average ranch in British Columbia. Here in this little valley, you see that a ranch has some hay fields, some grazing pastures, and those cattle would stay on that private land property and those hay fields and pastures from the winter months, possibly October through May. Now, if this rancher has a grazing agreement with the province, those livestock may be able to go out onto the Crown public land from maybe May until October or September, depending on those forage opportunities. Now you can see in this photo, some of this area on the southern part has been burned and it's been quite patchy. So it's possible that these cattle can now move into other areas. But what happens when you have a fire that is completely destroyed your range tenure or your range area? So going back to Kamloops. Before the fire, this area was forested. It had about 70% forest with about 30% open grassy areas. This would have been a Douglas fir forest with a bit of pine, and the understory would have been some pine grass. In those openings, you might have had some blue bunch wheatgrass and needlegrass communities. So that's the photo on the left is before the fire. Now, after the fire, that's the photo on the right. You can see that this fire destroyed that tree canopy and really completely leveled the playing field here. After the fire, there was a post-wildfire natural hazards risk analysis done. So this is looking at the soil burn severity. And this table is taken directly from that natural hazards risk analysis, and the findings are circled in red. So we can see that this was mostly falling into that high soil burn severity category, meaning that those litter layers were completely burned. The mineral soil exposure was quite high. And that would look something like this. So you can see that above ground layers, very burned, and you're not seeing a lot of those roots in the soil anymore either. So you wouldn't expect to have fire survivors. Given that this was severely burned, why are we even worrying about invasive plants if the invasive plants might not have survived that were there before? Well, when you do have a fire that is this severe, you can have changing fuel properties when you have invasive plants come into the site. So there can be an opportunity, for example, of cheatgrass, and that's in those photographs on those top right. When cheatgrass comes in, it can establish quite quickly and it can provide a lot of fuel in a short amount of time. And what this does is that it could shorten that time interval between fires, where now you have more fires more frequently, creating a feedback loop where now you have cheatgrass that's really dominating the site and not allowing for that native plant community to develop in that longer term. The objectives of this study. So we focused on 3 different areas. We wanted to see if by using seed and aerially seeding these areas, will this seed establish and how will each of the species perform? By seeding, will there be an impact to the invasives? So will it be such that when we establish an agronomic plant community, will it help that plant community be a bit more resistant to having those invasive plants come in? We also wanted to look at this in the longer term. So by seeding agronomics, are you shifting the successional pathways? And do you end up with a different plant community, significantly different than you would normally? And what does that mean in terms of forage? So after you seed agronomics, are you providing a boost in that forage opportunity for those livestock that are relying on this landscape to provide some nutritional requirements? So that area that was burned in 2003 was then aerially seeded in 2004. And this was done on a grazing lease. So this plant mix was selected, and this was the Kamloops Blue District Blue Tag mix seeding, and it was done at a rate of 5 kilograms per hectare. So this was the standard at the time. And in 2003, the policy wasn't that every fire gets seeded all the time. It was such that if there was a high burn severity area, there could be an opportunity to seed to create some forage opportunities. So you'll notice here, a lot of these are agronomics. The Western wheatgrass is the exception, that is a native grass. And what I've done here is I've put the common name, scientific name, and then I've included the percent of the mix by weight, by density. But what might be easier to understand here is when we're looking at the seeds per kilograms or the seeds per meter squared, because as we know, some seeds are really small and light and some seeds have a bit more heft to them. So I'd like to point out really that this seed mix was high in the Canada bluegrass component and the Italian ryegrass, and lower in the creeping red fescue. And we'll go through each of these one by one and how they performed after the fire. So the mix was aerially seeded in 2004 at a rate of 5 kilograms per hectare. And it was done in these 250 by 50 meter areas that were replicated across the site with an unseeded control. The vegetation was measured every year in Daubenmeier quadrats, 50 quadrats per site. The biomass was clipped in year 11 to ground level after these cages had been established to restrict grazing. And the analysis was done using a two-way ANOVA. So this site, there was no grazing in the first couple of years, but there were 50 cow-calf pairs, I believe, that were allowed onto the site and to this grazing lease into spring and fall grazing. Originally, the site was only grazed every other year, I believe in June. But it was observed that the site had quite minimal or moderate grazing through these years. In the following couple of graphs, I've got percent cover on one axis and then the years on the bottom axis. And what you'll notice is that I've blocked out the last couple of years so that we can focus on that first year of establishment, and then I'll reveal that persistence of the last couple of years later. We're starting just by going through all of these seeded agronomic species. So with Italian ryegrass, we've got the seeded in green and the unseeded control percent cover in black. And we've got standard error bars on there as well. So Italian ryegrass in the seeded area increased in percent cover in year 2 and dropped out by year 4. And this is something that we would expect. This is generally how the Italian ryegrass performs in other studies as well. So what this is doing is it's establishing really quickly, and then it drops out completely. And Lolium, it's a short-lived bunch grass. It's got these dense, shallow roots. It provides this quick ground cover, and it has good tolerance to grazing. So it's highly palatable and highly digestible. And we could consider this like a nurse crop. So it's providing that really quick cover when there's not a lot growing and when the area has a lot of bare ground and very susceptible to invasive plants. And then it doesn't persist later on. We also had that Rambler alfalfa and Canada bluegrass in the mix. So Rambler alfalfa and bluegrass both increased slowly, and reaching into year 4, we're getting to around that 10 and 15% cover. And it's higher in the seeded versus the unseeded control, although you'll notice that Canada bluegrass does have some percent cover in the unseeded control. And this could be for a number of reasons. It could be that with that aerial mix, there might have been some windborne seed that moved into the control, or it could have been that after the fire, there was 2 wet years. And so it could have been that there was some overland flow that moved the seed around into the control. So these seeds established, and they did persist. So you'll notice in that year 9, 10, and 11, those error bars are getting smaller. There's less variability in the percent cover of these species. And they are sort of staying around that 10 and 15% mark. So these have established even 11 years after the fire. Alfalfa has those deep tap roots, and there is some caution when we seed alfalfa because it can cause bloat if it's grazed in those early months. It does have that high forage yield and high crude protein content. Canada bluegrass, it is perennial and it is preferred by livestock, but we do need to be careful because Canada bluegrass can also be moderately invasive. So if you're introducing this into a community where it hasn't been before, it could also spread out into other areas. Moving on to Western wheatgrass, which was that one native seed in our mix. It was quite slow to establish, and that's not really a surprise. It has been known to have poor germination, and it usually ends up being subdominant in the plant community. It is rhizotomous and has fair crude protein content. The creeping red fescue was also a little bit slow to get going and to establish, and you'll notice the percent cover axes is different. So the Western wheatgrass, we're going up to 8, whereas the creeping red fescue, we're going up to 14, just to draw your attention to that difference. The creeping red fescue, high variability in percent cover through the years, and higher of both of these species in the seeded area versus the unseeded control. So they did come in through the seed mix. Creeping red fescue is palatable in the fall, and generally speaking, it's known to establish quite easily. The percent cover is a bit low here, but that could be because it was also one of the lowest percentages in our seed mix. There were some species that came in that we didn't expect. So smooth brome was one that came in, and it is more percent cover in the seeded area versus that unseeded area. And same with Kentucky bluegrass, which was highly variable through the years. And this could have been that these seeds came in through contaminated seed. So we do recommend that, generally speaking, when you're deciding to seed, you try and get the best quality seed to avoid situations like this and introducing these species that you didn't expect. Okay, so this is the result of the repeated measures ANOVA tests. And we're just looking at each of those seeded species, and I've included that Kentucky bluegrass and smooth brome that might have come in through that seed mix. And we're looking at the mean percent cover and the maximum percent cover, and we're just looking at that seeded and unseeded control numbers over the years. And I've circled in red to draw your attention to where the seeds percent cover was higher in the seeded areas. So we're just saying that, yes, these established in these seeded areas. And that NA there is the Timothy. So Timothy was in the seed mix and it didn't really establish in more than trace amounts. And not really sure why that is. So now that we know that these seeds did establish, were they effective in reducing the invasive plants into the area? So it was known that these areas were potentially going to be infested by plumeless thistle, toadflax, and the knapweeds. We know that these are species of concern in the area, but these didn't show up in more than trace amounts. And just a little bit of a comment on why we should be concerned about invasive plants after a fire. I wanted to point out and give an example here of a properly functioning plant community. You've got lots of plants here. We've got some bunch grasses, you've got a sagebrush and a lupin. And you can see here that when you have this good amount of biodiversity, each of these plants is occupying a different part of the rooting depth. So they are competing for nutrients and competing for water. And when you have these plants established, it's easier to avoid that invasive plant community from establishing. After a fire, you're starting over with plant community succession. And what can happen is that there is a pulse of resources after the fire. So you might have ammonium and nitrate in high amounts 1 to 3 years following a fire, in part due to that immediate release of organic nitrogen. And that can allow for rapid plant establishment. So you've got these early colonizers like cheatgrass that will come in and exploit those resources quite quickly, and then can make it difficult for those slow growing perennial systems to come in. So after the fire, if we can seed in a few agronomic species, it's possible that we can help moderate those available resources of that nutrient pulse and limit opportunities for these invasive plants to come in. So we didn't have those knapweeds come in or that Dalmatian toadflax, but what did come in was prickly lettuce and horseweed in higher amounts. So the prickly lettuce came in quite quickly, establishing in year 2 at around that 15%, and then dropping down by year 6 and really dropping out of the plant community, higher in that unseeded control. So that's the black line versus that green seeded line. And horseweed did something similar. So it came into about 8% by year 3 and then really dropped out of that unseeded control by year 6. So these are that early colonizers. These are these wind-borne seeds that come in quickly after a fire and establish. And what we're seeing here is that they didn't persist after year 6. What about the annual brome? So we talked a little bit about cheatgrass, and cheatgrass here is lumped with corn brome. They can be very difficult to tell apart in that vegetative state. And these came into very high amounts in that unseeded control. So we've got about 20% cover by year 6 and 7. And this is a fairly high amount. We're getting to that threshold level. Is this going to persist? Well, interestingly, this really dropped out by year 9 to 5%. And we're not really sure why. And we are missing information from that 8th year post-fire, which wasn't monitored. So that's interesting. Why did it drop off, and why didn't it persist at that high percent cover? This is the plant community just looking at those invasive plants. So we did also have common dandelion and tumble mustard come in at high percentages, and we'll talk about that when we look at that plant community establishment. So this is just showing that these weeds and invasive plants that we're looking at were higher in that unseeded control, suggesting that the seeding of agronomics can be effective in blocking these early wind-borne invaders after the fire. What about that forage perspective? So here at the top of this table, we're looking at those seeded agronomics and what they're providing of kilograms per hectare. This is after that, this is in the 11th year after the fire. And look at that total seeded species column. There is more forage produced by the seeded species in the seeded area versus the unseeded. Well, that makes sense. The seeded area had those seeded agronomics. But what about when we look at all of the other plants in the area? So if we also total in the native grasses and the native forbs, there isn't really a huge difference in forage production in the seeded versus the unseeded area. But of course, not all plants are equal. Some plants are providing more nutrition, more palatability, and more to those cows and their weight gain. So we have to look at and consider that lens of it as well. When we look at the community in a whole, what did these areas look like? So the seeded area, we've got here, I've listed the species on the left, and we have the seeded species or species that came in through the seed in the green. Those diagonal hash marks are those weeds, and then the plain black bars are the native plants. So in the seeded community, this was co-dominated by that Canada bluegrass and the Rambler alfalfa, which came in through the seed mix. We did have a bit of dandelion come in. That Western wheatgrass is coming in through that agronomic mix. And the native species are really in those small amounts, and that's yarrow, blue bunch wheatgrass, and Ross's sedge. Now, this isn't the whole picture. I think in total there were 105 species found, but we're just looking here at the top most dominant ones. How does that compare to our unseeded control? Well, in this area, we had dandelion dominating the site after the 11th year. Canada bluegrass, as we know, did come in either through some sort of drift. And we did have some native plants come in. So we've got more of that Ross's sedge, yarrow, and then we have Saskatoon, our native grass, that blue bunch wheatgrass, and timber milk vetch is coming in, which is our native forb. So we have here a greater dominance of the native plants. And it's interesting here as well because we have more forbs present, whereas in that seeded species, we have got more of those dominant grasses through the agronomic mix. So these plant communities, when we look side by side, they are different. And we have to be aware that by seeding these agronomics, we're altering that successional pathway. So here's a quick look at our native grasses. slow to establish. So that's our blue bunch wheatgrass and the Colombian needlegrass. They take a little bit longer to get going and establish on the site. So just wanted to bring this to your attention that there are more weeds coming into the area. One that we need to be aware of is that ventinata, also known as that North Africa grass. And there also is that Medusa head wild rye. So we have to really be diligent when we're looking for invasive plants, as there might be more that are coming in, particularly as the climate changes and as we're having more of these fires come through and this change in the fire regime. If you are deciding to seed, there are some really good documents out there. One I wanted to bring to the front is this British Columbia Rangeland Seeding Manual, and it has a decision aid here to help you decide if you're going to need to seed or not. So here we've got the decision going through looking at how severe that burn was, what the concerns are, and if you should seed or not seed. And if you do decide to seed, you need to consider your biogeoclimatic zone, the precipitation. It would be helpful to do a site analysis and really consider your objectives, whether that be forage, invasive plants, what kind of rehabilitation you're planning to do if the area is not logged or if it is logged. So when you do decide to seed, consider your objectives. Please choose your species wisely. Try and get that high quality seed. Consider your timing. These decisions need to be made quickly. Consider your post-fire operations. Is there salvage logging or not? And consider that you might need to also seed those guards, roadsides, and landings. The final thoughts. Did the seed mix establish? Most of the seeded species did establish as expected, except for that Timothy. And we did find that there was some persistence there as well. So that Canada bluegrass and alfalfa persisted. And there were a few species that came in that we didn't expect to come in through the seed mix. There is an impact to invasive plants. So seeding can be effective against those early colonizing wind-borne invaders. The forage production after 11 years was quite similar when taking into account the forage provided by that native plant community. The seeded plant community is different than that unseeded control plant community, particularly when we're looking at forbs versus grasses and those functional groups and how they break apart. The ecological impact of post-wildfire seeding needs to be looked at further when we are looking at those short-term benefits against some of the consequences and negative long-term impacts potentially. We need to understand the local impact of broadcast seeding with agronomics and be careful about how we're impacting and changing the succession of these ecosystems. We need to manage our crown forage resource for the livestock industry and take into consideration that ecology of the area in the long term. And it's good to think about these things now because after a fire, there can be a lot of public pressure to make a decision now as to whether to seed or not and what to seed with. So it's important to consider these management implications before it's an emergency. I'd like to acknowledge the work of Brian Wallace and Reg Newman, as this is their work. And I'd also like to thank Francis Jenga for allowing me to come to this conference. He's my supervisor. Thank you very much.